Today we are going to discuss the most important chapter of all time, functional equation. Without having a good knowledge in this chapter, it is not possible to solve problems in IIT-like entrance examination. Functional equation is involved in most of the sums in calculus given in such kind of pre-engineering entrance examination. So if you want to do good in exam, learn functional equation in depth. If you are visiting the first time my channel, make sure you hit the subscribe button and press the bell icon to get notified my new upload videos. If you want me to teach more like this, make a comment below. Enough talking. Let's directly jump to explore the chapter. Functional equation is basically an equation involving functions. So our prime task in this chapter is to evaluate, is to find out the actual function which is involved in it. Because the moment you get the actual function, you can go for differentiation or integration or whatever it is, right? So before starting the chapter, we must know some standard functional equation. The first one is, if f of x plus y equals to fx plus fy, then you write fx as ax. A is a constant, okay? If f of x plus y is equals to fx into fy, then you write fx as a to the power x. If f of xy equals to fx plus fy, then you write fx as a ln x. If fxy equals to fx into fy, you write fx equals to x to the power a. If f of x plus y divided by 1 minus xy equals to fx plus fy, then you write fx as a tan inverse x. Is it clear? If fx into f of 1 by x equals to 1, then you write fx as plus minus x to the power n. And if f of x, f of 1 by x equals to fx plus f of 1 by x, then you write fx as 1 plus minus x to the power n. Is it clear? You see, you can prove this very easily. See what I am doing. The given functional equation is, I am adding 1 in both sides we get. So from here, after factorization, we are getting let gx equals to fx minus 1. Therefore, g of 1 by x will be, is it clear? Therefore, this equation becomes gx into g of 1 by x equals to 1, right? So from here we can say that gx is nothing but plus minus x to the power n. Gx is nothing but fx minus 1, which is equals to plus minus x to the power n. So fx is nothing but 1 plus minus x to the power n. Is it clear? That's exactly what I have written over here. Now, if f of x plus y plus f of x minus y equals to 2 times fx into fy, then you can assume that fx equals to cos ax. Now, a very important functional equation we are going to explore now. So, learn it very carefully. If any functional equation is of type a f of x plus 2 plus b f of x plus 1 plus c f of x equals to 0, even if the functional equation is not in the form, try to bring it in this form by manipulating x in different ways, so that ultimate functional equation should give you in this form: a f of x plus 2 plus b f of x plus 1 plus c f of x equals to 0. Then let us assume that f of x plus 2 is m square fx, f of x plus 1 is m times fx, right? Therefore, our equation becomes am square plus bm plus c into fx equals to 0. Now, we are getting am square plus bm plus c. It's a quadratic equation. Since it's a quadratic equation, so three cases can arise. First is, if the roots, that is the values of m that we are going to get from here, are real and distinct. Let us say the roots are m1 and m2. Then you directly write fx as a into m1 to the power x plus b into m2 to the power x, where a and b are two constants. If the roots are real and equal, let us say the roots are equals to m, then you write fx as a plus bx into m to the power x. Is it clear? Now, if the roots are imaginary, let the roots be alpha plus minus iota beta, then you write fx as a cis theta x plus b cis minus theta x. What is cis theta? Cis theta is basically nothing but cos theta plus iota sin theta. Cos theta plus iota sin theta can be written as cis theta also. Now, what is theta? Theta is nothing but tan inverse mod beta by alpha. Okay, so if you can remember this much, I think your functional equation problems will get easier. Now let us start problems based on functional equation. See this question: if fx is a polynomial such that fx into fy equals to f of xy minus fx minus fy, this functional equation is true for all x, y belongs to real numbers. Okay, so in place of x and y you can put anything. So how to do this problem? How to start this problem? If you observe carefully, you will find this functional equation is not representing the standard functional equation that I have given you right now. Okay, so I have to convert it in the standard functional equation, right? So here what I am doing, I am taking everything in the left hand side except f of xy. So we are getting basically, is this clear? Now I am adding 1 in both sides we get. So left hand side we are getting fx plus 1 into fy plus 1 equals to f of xy plus 1, correct? Now still we are not getting anything as a standard functional equation. So what to do? Let me define another function, let us say gx, which is equals to fx plus 1. Therefore, the left hand side becomes gx into gy equals to g of xy. Tell me yes or no? Right? Now, this is our standard functional equation, yes or no? So, we can write gx is nothing but, what we will write? If gxy equals to gx into gy, what we will write for gx? We will write gx as x to the power a, correct? Gx is basically fx plus 1, which is equals to x to the power a, implies fx is nothing but x to the power a minus 1. Now they have given f2 is 7. That is 2 to the power a minus 1 equals to 7 implies 2 to the power a is 8. That implies a is nothing but 3. Yes or no? Therefore, our function becomes x to the power 3 minus 1. Is it clear to all of you? Hello? Okay, now the value of f of minus 2 will be minus 2 whole cube minus 1, that gives you minus 8 minus 1, which is nothing but minus 9. Therefore, your option D is correct. Is this problem clear to all of you? Okay. In this problem, they have said that if f of x minus y, fx into fy and f of x plus y are in AP, for all xy belongs to R and f0 is not equals to 0, so we have to prove that fx is an even function and f dash 2 plus f dash minus 2 equals to 0. Now what we will do here is, first we will solve the problem by using our standard functional equation. And then we will do the same problem without using our standard functional equation, and there we will see how to approach the sum even if we forget the standard functional equation in examination, right? So first of all, they have said that these three functions are in AP. So we can write 2 times fx into fy equals to f of x plus y plus f of x minus y, correct? Now, from the standard equation, from the standard functional equation, we can say from here that fx is nothing but cos ax. Am I correct? Now, the moment you write fx equals to cos ax, obviously, this function is an even function, right? It's an even function because cos ax is an even function. So, the first part is proved. So, for the second part, what I am doing, I am just differentiating this function to get a sin ax, right? So, f dash 2 will be minus a sin 2a and f dash minus 2 will be minus a sin minus 2a, correct? So, f dash 2 plus f dash minus 2 will be nothing but which will get cancelled. So, answer is 0. Proved. Is it clear? So, that is the advantage if we can remember the standard functional equation. It will make the problem much easier and we can solve it in a very quick succession, right? But suppose if we don't know, we have forgotten the standard functional equation, in that case what we will do? We have been given, okay? So let me put first x equals to y equals to 0. So we are getting f0 plus f0. So we are having basically 2f square 0 equals to 2f0. They have already said that f0 is not equals to 0, right? f0 is not equals to 0. So we can cancel f0 from both sides. We are getting f0 as 1. Is it clear? Now, in the functional equation, let me put y is equals to x. So we are getting what? 2f square x equals to f of 2x plus f of 0. That implies 2f square x equals to f of 2x plus 1. Is it clear? Have you understood till this? Okay. Now, in the functional equation we are putting, since we have to show that fx is an even function, so what I am doing here is, we are putting y as minus x. So we are getting what? 2fx into f of minus x equals to f of 0 in plus f of 2x. So 2fx into f of minus x equals to f0 is basically 1. So 1 plus f of 2x, correct? Is it clear? Now we have already shown that 2f square x is equals to f of 2x plus 1. Therefore we can write 2 times fx f of minus x equals to 2f square x, correct? So taking everything in the right hand side and we are taking fx common, so we are left with fx minus f of minus x equals to 0. So either fx equals to 0 or f of minus x is equals to fx. From this both cases we can say that the function is an even function. But see the difference, if we can remember the standard functional equation, the problem can be solved within 3 seconds or 5 seconds maximum. But if you cannot remember the standard functional equation, then you have to go through this long process to show that the function is an even function. Is it clear? So I have simply, till now I have simply proved the first part of this question. Now for the second part, we are differentiating. So we are getting minus f dash, we are differentiating this equation. So we are getting minus of f dash minus x equals to f dash x, right? So in place of x, if I put 2, so we are going to get f dash 2 plus f dash minus 2 will be equals to 0. Is it clear? So this is the second part of this question which is proved now. Is it clear? So I always suggest for West Bengal JEE like examination where time is a major constant, you should remember the standard functional equation to solve the problem easily and in less time. Is it clear? Now let us move for the next problem. In this question, fx plus f of 1 by x is equals to fx into f of 1 by x. Again, it's a direct question from functional equation. Those who have remembered the standard functional equation, they can solve this problem in less than 10 seconds. Because we know that when the functional equation is of this kind, then your function fx can be written as 1 plus minus x to the power n, right? Now they have said that f of 3 is 28. That is 1 plus minus 3 to the power n is 28. So that implies plus minus 3 to the power n is 27. Now since 27 is positive, so negative sign is rejected. So from here we are getting n is nothing but 3. Therefore our function fx becomes 1 plus xs cube, right? So the value of f2 will be 1 plus 2 cube, that is 9. Yes or no? It's a straightforward question. Those who can remember the standard functional equation, they can solve those kind of problems in much less than 10 seconds. Okay? Now, let us take another problem. Now, in this problem, they have said that f of x plus 2 minus 5 times f of x plus 1 plus 6 times f of x equals to 0. I taught you a method that whenever you find any functional equation is in this form, then what we do, we replace x plus 2 by m square fx and f of x plus 1 as m into fx. We replace f of x plus 2 as m square fx and f of x plus 1 as m fx, right? So the quadratic equation ultimately that will be generated in terms of m will be m square minus 5m plus 6 equals to 0. Yes or no? Now, if I factorize this, we are going to get m minus 2 into m minus 3 equals to 0. That implies m is coming to 2 and 3. Yes or no? Now the two roots of m are real and distinct. Now we can see from here the theory that I have given you. You can directly write your function fx as a m1 to the power x plus b m2 to the power x. Therefore, we got the function fx as a into 2 to the power x plus b into 3 to the power x. Now they have given f0 is 0 and f1 is 1. Let me put those values in the derived function we get. Is it clear? Now we have to solve these simultaneous equations to get the values of a and b. So what we are doing here, it's a pretty simple thing. Is it clear? So we got a as -1 and b as 1. Therefore, our function fx becomes, is it clear? Therefore, f of 2008 will be 3 to the power 2008 minus 2 to the power 2008. Okay? Now, the question is we have to find out the least positive prime factor. Now, if you go on factorizing this, there will be one term. The first term that you will get is 3 minus 2. Then you will get 3 plus 2 and so on. Right? 3 minus 2 will yield 1 and 3 plus 2 will yield 5. Now, there may be prime numbers in the other factors. But we are not interested for those factors because here we have to find out the least positive prime factor, which is nothing but your 5 here. Is it clear? Therefore, your answer will be 5 in this case. Okay? Now, let us move for another problem of this kind. This is again the similar kind of problem. So, in this case, our quadratic equation will become m square minus 4m plus 4 equals to 0. Right? Therefore, it is m minus 2 whole square is 0 implies m is 2. Therefore, for this quadratic equation, the roots are real and equal. Now we know that when the roots are real and equal, the function will be defined as a plus bx into m to the power x, where m is 2, so it will be 2 to the power x. Is it clear? Now they have said that f0 is 0 and f1 is 1. So let me put those values in this function to get the values of a and b. So I'm doing it little quickly. Therefore, the function becomes is it clear? Therefore, our f10 is, so that gives us (5120). Therefore, the required value of f10 is 5120. Have you understood this problem? Now let me take another sum. Here you see the given function is f of x plus 1 plus f of x minus 1 is equals to under root 3 fx, right? Now in this case, the function is not in the form of a into f of x plus 2 plus b into f of x plus 1 plus c into fx equals to 0. It is not in the form like this. So we have to manipulate the values of x so that this equation becomes in the form of this equation, right? So in place of x I am putting x plus 1 we get. I am taking everything in the left hand side, so we get. Therefore, our quadratic equation becomes, is this clear? Now let me solved by Sridhar Acharya's method. So we are getting m is equals to, is this clear? Function can be written as, can you remember it? A says theta x plus B says minus theta x, right? Here you see it is in the form of alpha plus minus beta, right? Here alpha is root 3 by 2 and beta is half. Therefore your theta is nothing but tan inverse mod beta by alpha, that gives you tan inverse 1 by root 3, which is nothing but pi by 6. Is it clear? Therefore our fx becomes, A says pi x by 6 plus B says minus pi x by 6. Is it clear? So let me just open. So we are getting fx as this is not B, this should be A. Okay. So we are getting, now they have given us that f2 is 2. f2 equals to 2, which is nothing but a plus b cos pi by 3 plus iota a minus b sine pi by 3, right? Now if we compare, we are going to get a plus b by 2 equals to 2 and a minus b root 3 by 2 equals to 0. So solving this 2, we are going to get a plus b is 4 and a minus b is 0. That implies a is equals to b equals to 2. Is it clear? Therefore our function fx becomes 4 cos pi x by 6. Is it okay? Therefore f of 4 will be so answer is minus 2. Is it clear to all of you? Have you understood this? Okay.